Hello friends, in this video we are going to learn about the LU decomposition method. So this is another method for solving out the system of linear equations. So in this method what we do is we factorize a given square matrix. As you can see the definition that LU decomposition of a matrix is the factorization of given square matrix into two triangular matrix such that the product of these two matrices gives the original matrix. So we have a matrix X. We broke down this particular matrix into two sub matrix, which is lower triangular matrix and upper triangular matrix. So the A will be equals to LU. If LU is multiplied with each other, it will give us a value A. So the lower triangular matrix will be like this. The diagonal elements will be 1 in this case, and in the upper triangular matrix the lower triangular values will be 0. So if you multiply these two things, it will be equals to A. So I took an example over here to figure out the value of u11, u12, u13 so that we can find out the lower triangular matrix and the upper triangular matrix. So as you can see that u11 is equals to 1, so I am putting u11 is equals to 1, u12 is equal to 2, so u12 is equals to 2, u13 is equals to 4. If we apply these three values in the second row, you can get the value of L21, U22 and U23. So the value of L21 will be 3, it will be 2 and it will be 2. And if you put these values in the third row, it will give the value of L31, L32 and L33. Sorry, it's U33. So the value will be 3 and L32 will be 1 and L31 will be 2. So here you can write down the matrix A, which is 1, 2, 4, 3, 8, 14 and 2, 6, 13. So we have find out the L and U. The L will be 1, 0, 0 and L2 value is 3, 1, 0, L31 is 2, L32 is 1 and 0. The U value is U11 is 1, U12 is 2, U13 is 4, it will be 0, U22 is 2, U22 is 2 and U33 is 3. So this is our A, this is our L and this is our U. Now the question comes is that how we can solve this system of equations with LU decomposition. So let's formulate that thing. We will have a matrix in the form of AX equals to B. So first of all what we have to do is we have to break the L into L and U. After breaking it into L and U, we have to consider UX as a single variable Y, and then we have to find out Ly putting B as an equal, and we have to solve for this Y. Once we are having the solution for Y, we know that Ux is equals to Y, so we have to find Ux equals to Y so we can solve for the X, and that X will be the answer. So I am taking this particular matrix as an example so that I don't have to solve the L and U in this case. So the matrix that I am having is this one. This is the coefficient matrix and this is the right hand sides of that particular thing. So I already have the L and U for this thing, so I put the L and U, so and the X along with the right hand side. So I considered Ux as Y, and so now what I have to do is we have considered Ux is equals to Y, and now I have to find out the L. Y is equals to P. So I am doing this thing in this step. So the L is 1, 3, 2, 0, 1, 1 and 0, 0, 1, and I am considering Y as Y1, Y2, Y3, that took three values Y and putting the right hand side as it is. So here you can see that if you multiply this one with this one and this one, so that we can have three equations and we can find out the values of Y. So 1Y is Y1, which is equal to 3, 3Y1 plus Y2 is equal to 13, 2y1 plus y2 plus y3 is equal to 4, which is this matrix. So using these three matrices we can find out the value of y. Y1 is 3, this one, and if we put 3 value over here it will be 9, and if I subtract 9 from 13 it will be 4. This is the value of y2. Similarly we find out the value of y3. So we have solved for y. After solving for y, we know that ux is equals to y. Now I have to solve for the x. So I am taking out this u value and put it over here, and took 3 variables of x with the solution y. And now I again have to multiply with this 1 by 1 so that I can have these two rows. I multiply this one with this one, and I got this one. Multiply this row with this column, got this. Multiply this one, this, I got this. So if I substitute these values and find out the value of x1, x2, x3, it will be like this. So as you can see that this is a lengthy process, and for this particular thing you have to consider, you have to take some more time. So I will recommend you to not to go with this particular method in CADE. So try to stick with the Gauss elimination method. In the next videos we will learn about the eigenvalues and eigenvector. So if you are liking this video, these videos are beneficial for you, please hit the like button, subscribe us, and share it with your friends as well so that they can be benefited as well. Thank you.